Hello guys, welcome back to our YouTube channel. Today we'll be using the Boston housing dataset from Kaggle. You can download it uh, here. We'll be doing prediction on Boston housing prices of the houses using multiple linear regression. I'll be using Google Colab for Python coding. I find it very convenient because you don't have to install an explicit application for Python. So this is very useful for people who do not have Python in their laptop. So let's begin. Prediction of Boston housing prices using multiple linear regression. Okay, now let's go. First, we'll have to download this dataset. I have it already downloaded and kept it in my folder. Now we'll have to import them again using the import function over here, upload function over here. After uploading, you can just copy the path and use it here. So first, let's import pandas for loading the dataset. So import pandas as PD, and let's give the variable name as df. PD dot read csv. Oh, sorry. PD dot read csv, and let's give quotation mark. And we can copy the path, double click it, copy path, control V. Okay, now let's check whether the import has been done successfully. PD dot head. It'll give you the first 5 observations. Okay, it has worked properly. Good. Okay. Now, let us check what each column represents back in Kaggle. Prim is per capita crime rate per town. ZN is a residential land zone. Indus, proportion of non-retail businesses. Charles River dummy variable. If there is a river, it is 1 or else it's 0. NOx, nitric oxide concentration, tells you the pollution level. RM, average number of rooms per dwelling. Age, proportion of basically the age of the house. This distance to 5 Boston employment centers. Rare accessibility to radial highways. Tax, full value property tax rate. P ratio, people teacher ratio by town. B, proportion of blacks by town. L stat, percentage low status of the population. These are all the independent variables, and this is the target variable or the output variable. MEDV, median value of owner occupied homes. So this is basically the price. I would like to change the column name MEDV to price. For that, let's rename it. Rename the column name MEDV to price. Df is equal to df dot rename, use a rename function, columns equals dictionary, medv, and the new column name price. Okay, now let's check whether it has worked properly. Go ahead. Yeah, you can see there is a change in the column name. Now let's divide the data set into x and y, that is the independent variables and the dependent variable. So independent variables are called x, and the dependent variable or the target variable is called, sorry, oh, variable is called y. Made the same mistake here. So x is equal to df dot I log all the rows, comma, from the beginning till the last but one column. And next, y is equal to df dot I log all the rows, comma, just the last column. Okay. Now we'll have to use data frames or multidimensional arrays to, it's better to use those with linear regression models. So we can see that the type of X is a data frame. Okay, so that is good. Now let's check what the type of Y is. Next type of Y, it is a series. So we will reshape this using the reshape function. Arrays dot reshape -1, comma 1. Now if we check, it's an n-dimensional array. Now this is good to be used with linear regression. Now let's start the linear regression. First import the linear regression. Library and module function, sorry. Function from